Hello everyone. So today let's solve the problem number 371, sum of two integers, right? So there is a twist in the question. So they won't be asking like if you add if you have two numbers, just sum of this one. Go with the sum of two numbers, right? So we can just go with the return a plus b. We have some other methods as well. We can just go with one line, right? So here see what the question states here. We are given two integers a and b. We have to return the sum of the two integers without using the addition operator and this one subtraction operator, right? Plus and minus basically. The example they have given here is A1, B2. So when we add 1 and 2 respectively, we will get 3. Same goes with the example 2 as well here, 2, 3. So we'll get the output 5. So how can we do this basically, right? So we can just make use of the this one. We can just go with a bit manipulation to be frank. Just give me a second. One more thing. I just want to tell you here is we will be going with a bit manipulation approach for this particular problem, right? Just remember this one, right? Now, let's consider this first example. The same thing for the approach. The first example will be considering for the approach. So the first step here is we will be representing 1 as well as b in the binary. So 1, we can just give here this one. What do we call 0, 1? It is represented in the binary. As 0, 1 basically. 2, we can just represent this one as 1, 0 in the binary, right? Now what we will be doing, we will be performing XOR, right? So we will be performing XOR, right? XOR, what it does, it gives the sum without carry. It gives the sum without carry, right? So we will be going with 0, 1 XOR 1, 0. First we have converted to the binary, then we are performing XOR here. This will be 0, 1 XOR 1, 0, which will be 1, 1 basically. If we convert this 1, 1 to the binary, we get 3, right? So we got 3 now, right? So now what we will do, we got basically 2 plus 1 is 3, right? So and we will be going with a bitwise AND here, which gives carry in case if we have carry. So in for this particular this one example, we don't have carry, these two, right? So 2 and 3 we have 5. 1 and 2 we get 3 directly. What if we have 5 plus 7, something like that? We have to go with the carry and we have to the output will be 12, right? Sorry, the output will be 12, right? So here in that case we'll be making use of the bitwise AND as well, which gives carry, right? So here in this case we will be performing and we'll be going with a bitwise and here this will be 0, 1 and 1, 0, which will give us the this one output 0, right? When we make use of the bitwise AND basically. And if you know the truth table bitwise AND basically only we have two ones basically, then it is 1, or only we have true, then it is true, else it is false. 0, 1, this is 0, 1, 0, 0, and 0, 0 is also 0. This is for the this one bitwise AND basically, right? So this is fine. Now AND gives the carry 0, 1 and 1, 0, 0, 0. Left we'll be making use of the left shift operator. So we'll be going with a left shift 1. So this one, left shift operator 1. So this will lead to 0 itself. This will totally lead to 0 after performing the left shift operator 1. So this will lead to the 0. Now what we'll do, we'll add the sum without carry and carry recursively. So this one will be, we got 3 here, 3 plus 0 we got here, right? Carry. So this one will be 3 plus 0. What will be the output? 3 plus 0 is nothing but 3 here. So we'll stop when carry becomes 0. Basically, we have got the carry 0, right? So we will display this one as the output 3. So the output that we got here is 3, which is equivalent to the output that they have mentioned for the example 1 within the question. Very simple one, right? Extremely simple one. So this is how we can make use of the bit manipulation. All we have made use of here is one as XOR and AND. So you have to know how XOR and AND works basically. Simple, right? We have solved many problems by now. We should be knowing XOR and AND. We have almost come to the end of the bit manipulation problems, right? So we are left with 2 or 3 problems to solve basically. Now I hope this one approach part is completely clear. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would be big of 1. Why it is big of 1? The time complexity, why it is big of 1? Because we have maximum 32 iterations for the 32-bit integers, right? So time complexity would quite obviously fall in this one, big of 1. So what would be the space complexity here? The space complexity would lead to big of 1 as well, because we will be going with only constant extra variables, right? That is the reason space complexity would be big of 1. The time complexity and the space complexity would lead to big of 1 for the code that we'll be writing in the future. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. This is easy, man. First, let's repeat until the carry becomes 0, right? So I'll just go with the while loop directly here. While b not equal to 0, then what we will do? So this is not equal to. So, yep. Then within the while loop, what we will do? Uh, let's find the carry bits. Meaning, let me initialize carry a, assign this one to a bitwise and b, right? So this one we have already discussed. And what was the step 2? We have to sum the bits without carry using the XOR, nothing but a XOR b, right? I have shown you this one in the within the approach. Now let's shift the carry left to add in the next iteration. This will be b equals carry left shift 1, right? So this is fine, I believe. What we are doing now here, this one we are shifting the carry left to add in the next iteration. Now the final step would be when carry is 0, a contains the final sum, right? So we can just return a here. Simple. We are done with the code. Let me format the code once and let me hit the run button. So the sample test cases are getting passed. So let me hit the submit button. Now I hope this works for all the test cases, man. Yeah, all the test cases are getting passed. Means whatever the code that we have written works absolutely correct, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.